Sounds like an interview.
All right. Do you want me to start with a story as a bit of a background and definition of where we are?
Yes, well, I'll give a little introduction. Tonight we're having a C.A.S.H meeting, and our guest tonight is Glenn Bell, who's president of Drought, Adaptation Industries.
Perfect.
And so Glenn, can you give us a little history and the story of your product?
Sure. About 23, 24 years ago now, I was a part of an engineer, inventor think tank. It was an online think tank. And back when the internet was really fast, remember that with the dial-ups? Anyway, there was about 30 of us with this group contiguously or continuously, and we were approached by a representative of DARPA. Everybody know who DARPA is? Those that don't, it's a kind of a branch of the military-industrial complex that works in usually advanced weaponry. Anyway, we were talking about DARPA, right?
Yes, you were in DARPA, and you had a special interest think tank group.
Yeah, well, not really special interest. We were inventors and engineers, and had a number of things under our belts, things that we'd done. And anyway, we were approached by, this was before DARPA was doing their outreach programs. I don't know if you remember, you know what they're talking about now where they have all these challenges and all this stuff that goes on now. They didn't have those things back then. But anyway, they'd identified a bunch of problems that they wanted to get some, I guess, outside influence or input on, and that was the biggest one, or the one that got my attention, was being able to grow food in drought on a whole lot less. They'd identified the fact that most people didn't have the ability, the knowledge, or even the ability to gain the knowledge on how to grow food, one. Two, even when they went out and sought the knowledge, they failed usually miserably, according to DARPA, about 98% of the time. And when they did fail, it was a catastrophic failure for them financially as well as for the environment, right? So they wanted somebody to figure out a way to make it possible for them to grow food on less water, less amendments, less chemicals, less labor, and a whole lot less knowledge, and make it a lot less expensive. Because if you were to price out what a garden cost in labor, based at $15 an hour and the additional water and everything else added to it, if you started out with no tools, literally for a family of four, it would cost you around $4,000. And if you have a 98% failure ratio, it's just catastrophic. So especially when you have a young family that have a combined income of $28,000 a year, that $4,000 is almost 25% of their income, and it just failed. It just all went into the dirt. So anyway, I thought it would be easy. always the famous last words, right? So I ended up spending a number of years just with the physics of it. Just to identify the problem, you have to really, 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 really research, right? And there's really, when you're researching problems out there, there's no such thing as going to a Google search and searching how to grow food in drought. I mean, you can do that, but you're not going to get really complete answers. And so anyway, I started looking at it and what the real problems was. And Robert can tell you, one of the first things they teach you in engineering 101 is, the harder and deeper you look into the problem, the more and more the solution will avail itself, right? Yeah. And anyway, after I identified four major problems in growing food in drought. One is almost all the water you use is wasted. It either is.
Okay, keep going. Are you still there?
It's either wasted because when you put water on the ground, water seeks its simplest path, right? Or the least resistance. Right. Two, 2, very seldom does it even get to the root zone. 3, when you do put it on the ground, what it ends up doing, what doesn't evaporate ends up feeding and watering the weeds. So that's one of the problems. Hydrolysis, thermodynamics. One of the things I did not find in my research going out looking what actual soil temperatures are and what the comfortable soil temperatures are for roots and different kinds of plants and the critical throat of the plant, right? So that was a problem that had to be dealt with. So anyway, to make a really, really long story short, after about 7 years, I knew what the solution was. I didn't know how to fix it, how to make it usable by other people. Because it's one thing to have the solution on paper. It's one thing to have the solution even in prototype form. But it's no good unless you can actually put it in somebody's hands who has absolutely no experience. And they have to have the ability to transfer that into practicality. So anyway, that was the outcome of that was, can you see this? This is the drought rate. All right. And it took years and years to get to that. And what that is Robert, you've seen these. Did I give you any of them? I should have given you a couple of them. This is compressed. This is it's about 7 different kinds of compost and a few other things that aren't compost added into it for binding materials, things like straw. I have some chipped wood structure in there. All of these are natural products that when introduced into soil will decompose and become long-term food. And what it really does is when you take this, it's really tough to do this online, but I'll show you. When you take this, you bury it to grade. The top of this ring is actually surfaced to the grade. So by doing that, and then you take it and then you hollow out the interior. So in essence, you've built a fancy hole in the ground. That fancy hole in the ground, the difference is at the top of that surface layer, you have soils that are ranging between 125 on a hot day, anywhere from 125 to 185 degrees in surface temperature. And that will go down as deep as 2 inches. And when you start taking temperatures in the soil, you find out that, vegetative matter is cooked at 110 degrees.
Yeah.
So, and there's not really a plant out there that you don't put the seed in like a 1/4 inch of soil or even a 1/2 inch of soil. That young seedling is exposed directly to that extreme heat. And so, and then people wonder why you can't grow anything in southern New Mexico temperatures, right?
Yeah.
So, by hollowing out the interior, what you're actually doing is you're making a concave arena that is quite similar to a basin gardening system. However, it has a very structured wall and it's set up in a round shape because if you take the track of the sun, you basically carry that same shade pattern all day long.
Yeah.
The base of the ring. So it's a way to feed and water and take care of the fruit producing plants from germination to maturity. So that's that particular product. So what they asked me to do is actually make it so simple that anybody could do it. So after I identified the ring, then I went ahead and built these. This is a food pie. This is a food pie. I want to do 3 or 4 seeds that are wrapped in natural cellulose, shredded paper, right? That is encased in this particular type of paper, which is actually known as spy paper. So when this comes in contact with water, all of the outside film on this totally dissipates to nothing. Okay. And the seeds that are wrapped inside the shredded paper, paper, like any other kind of cellulose, holds the moisture on the seed as it's under a 1/2 inch of soil at the bottom of that ring. And so what this has done, and we tested out, we've had 10-year-olds plant gardens in 10 minutes.
Huh.
And